This video is going to cover polynomial inequalities. Starting with our very first warm-up question, what would the solution be as an interval for x is greater than or equal to 0, and where would you shade? Well, if I'm thinking about x values being greater than or equal to 0, and thinking about all of my positive x values, so I would shade on this side. If I'm writing it as an interval, I would have 0 to infinity, including the 0, and that would really be essentially a domain. And for a solution for y is less than or equal to 0, I would have negative infinity up to 0 with a bracket, and I would actually be shading below the axis because this is where my y values smaller than 0. Number 3, if you were asked to find a solution as an interval for f of x is greater than or equal to 0 for this quadratic, would you be finding x values, y values, ordered pairs, or regions that satisfy? We're looking for regions that satisfy. Essentially, what we're saying is that if we're looking for a function where f of x is greater than or equal to 0, you're looking for where around this function does that happen. You're going to be looking for regions that satisfy. Leads us into the actual inequality portion of the polynomial. So it's going to look really similar to what we've done before with factoring polynomials. It should also remind you of when we did rational inequalities and we had critical points in a number line. So the directions are here, 1 through 4. I'm going to go ahead and go right into the example. You can read through these on your own if you want. So here we have something that is factorable by grouping. So let's take out an x, and then we have x squared minus x minus 6, and then that quadratic is factorable. And that's how we end up with this factored meal. Okay. Notice it says less than 0. What you're going to do now is each of these x values are going to be considered a critical point, because that is where the x values will make the function 0. Notice it says less than, so these are values that would not be included. From there, you can plug in any point in any of the 4 intervals to check your math and see where your values are less than 0. So I'll plug in -3, I'll do -1, 1, and 4. Near room, just make sure. So if I plug in -3, -3 times -3 minus 3, -3 plus 2. Need to do some math here. That's a negative times a negative times a negative. Negative, so that works. If I plug in -1, I'm going to have -1 minus 3 times -1 times -1 plus 2. Negative, negative, and a positive. So that's not going to work. If I plug in a positive 1, I have 1 times 1 minus 3 times 1 plus 2. That's a positive, negative, positive, which will be a negative number. And finally, if I plug in a 4, I have 4 times 4 minus 3 times 4 plus 2. And these are all positives, so that does not work. So what I've just found out is that -3 worked in my interval, so this section works, and the 1 worked, which means this section works. See how we want to write that as an interval, negative infinity to -2, not including 2, union or and 0 to 3. So if you were to look at that on a graph from 0 to 3, this is where f of x is less than 0, and then going to the left, negative infinity. we would have x be less than 0. Okay, the rest of this section is just practice problems, so we'll go ahead and do those. If you want to pause the video here and try to work through these on your own, feel free. Come back when you're ready. This is factorable by grouping. I'm going to go ahead and take out an x squared. I'll have x3, take out a -9, and then you'll have x3 again. I'm going to have x squared minus 9 times x minus 3. This is x plus 3, x minus 3. So I'm actually just going to rewrite it this. From here, I can also do my number line. -3 and a point at 3. Those are my critical points. In this case, those would be closed circles or brackets since it says less than or equal to. So we'll try 0, we'll try 4, we'll try -4. I am going to start with 0 because that one's nice and easy. I know that if I plug in a 0, I get 27. That's not going to work. What's probably going to happen is that -4 and 4 will work, but I'll do both just to check. So we'll have -4 plus 3 times -4 minus 3 squared. That's a negative, that's a positive when squared. So yes, this is in fact less than 0. If we do the same with +4, times 4 minus 3 squared will actually be, let's see, a positive and another positive, but in fact does not work. So we actually just only have one section that works. See what worked, -4. So that side, writing my answer with interval notation would be -infinity to -3 with a bracket on the -3. Okay. Moving on to the next one, also factorable by grouping. Take out an x squared, take out a -8, going to give us x squared minus 8, 11, greater than equal to 0. So this will be the square root of 8, which is roughly 2.7. But don't forget that's going to be a plus minus. And then we have x equals 11. So on our number line, a couple sections, we'll have -2.7, we'll have 2.7, and we'll have 11. And we can choose some points to plug in. I'm going to again start with 0. 0 is going to work for me, so I'll check one off. Let's go ahead and do 12. We have 12 squared minus 8 times 12 minus 11. That's positive. That's positive. Going to work. On first glance, it looks like the 3's aren't going to work, but I'll go ahead and do that anyway. We have 3 squared minus 8 times 3 minus 11, so that's a negative and a positive. That won't work. And -3 squared minus 8 times -3 minus 11 is a positive and a negative, and that does. So we have these yellow intervals that are going to be our solution. We want to write that. We'll say -√8, but +√8 in brackets, and bracket 11 to infinity. Moving on to the next one, this one's a quadratic, so we can immediately go into factoring. So we have x. See, we're multiplying to get 15, adding up to -8. So I'm thinking -5, -3. which means on our number line, we'll have a 3 and a 5. Plugging in some points, I'll do 0, 4, and 6. I can immediately check 0. When I have a 0, I end up with 15. It's not going to work for us. If I plug in a 4, I'll have 4 minus 5 times 4 minus 3. That's a negative and a positive, so that's going to work. And if I plug in a 6, I have 6 minus 5 and 6 minus 3, which is positive and does not work. So that means our solution will just be in the center from 3 to 5. Our very last one, also factorable by grouping. Throw out that -9. I don't know why I started on the right, but decided to do something different. Right, we have x squared minus 9. Again, we had that earlier, but don't forget that's going to be plus minus 3 and 2. So let's make our number line. -3, 2, and 3. So yes, unfortunately, that means you're gonna have to plug in 2.5 or some sort of decimal because you have um, critical points at 2 and 3. Starting with 0, 0 is gonna work because that's gonna give you that 18, and that's greater than 0. Um, -4, when we plug that in, we'll have -4 squared minus 9 times -4 minus 2. That'll be positive, that'll be negative, that's work. I know 2.5 is also not gonna work, but let's go ahead and do that math. 2.2, this will be negative, this will be positive, which gives us a negative. And then if I plug in 4, 4 squared minus 9, which is a positive, times 4 minus 2, which is positive, so that section will work. So in yellow, we have our solution. If you want to write it in interval form, we'll have -3 to 2 in parentheses, union in parentheses 3 to infinity.